What is going on, guys? Welcome back. In today's video we're going to learn how to use machine learning to find celebrities that look just like you. So let us get right into it. Alright, so what we're going to do in this video today is we're going to use machine learning in order to find celebrity lookalikes for a given person. And we're going to do that by taking the image of that given person and comparing it against a database or a data set full of images of celebrities, and then returning the closest match or even sometimes an exact match if the similarity is high enough. And the similarity will be computed by a machine learning model. It will look at two images and say that they are similar on a certain scale, and if they're similar enough, it will say that it's an exact match, and in this case we can just immediately return the image or the name in this case, and otherwise we're just going to return the closest match, the match with the highest similarity. That's the basic idea for this video today, and for this we're going to use the celebrity face image dataset from Kaggle. You will find a link in the description down below. However, you can of course use any dataset full of faces. It doesn't have to be a celebrity dataset. You can just match with ordinary people. You can just find lookalikes in a large database of people in general, which can maybe even be more interesting. But we're going to use the celebrity face image dataset for this video today. And this dataset contains images of 18 different celebrities with 100 images per celebrity. We have Brad Pitt, we have Megan Fox, we have Tom Cruise, and a couple more. So what you want to do is you want to download the dataset, you want to extract the directory that this zip file contains, and you want to put it into the same direction as your Python file. In my case, I'm going to use a Jupyter notebook. So I have my notebook here, and I have the celebrity faces dataset here with all the different celebrity directories, and you can see that each celebrity has their own directory, and when you go into it, you can see 100 images per celebrity. So we have Brad Pitt 1, Brad Pitt 2, Brad Pitt 3, and so on. Different perspectives, different points in time, different haircuts, but we have the same celebrity 100 times. And this is true for all these 18 celebrities. In addition to that, I also have 4 images here, one random person from Google, another random person from Google. Then I have an actual match for Brad Pitt, which is Brad Pitt himself. And then I have a lookalike, a person that looks like Brad Pitt, but is not Brad Pitt. Those are the 4 images we're going to use for this video today. And you want to take those or I'm going to take those and match them to the data set and find, hopefully in this case, Brad Pitt being the highest match or the closest match. Hopefully in this case, finding that Brad Pitt is the actual match, the exact match. And in those two cases, finding at least someone who looks similar. That would be the ideal outcome. You can use whatever images you like. You can use yourself, someone you know, or some random image from Google, or multiple random images from Google. But yeah, that's up to you. So what we want to do here first in order to save some time and to keep things simple is I don't want to go through all the 100 images per celebrity. I just want to use the first one of each celebrity and then match just this one image. So I want to see how similar is a given image like this guy here to all the different first images. So this image here and this image here and this image here, just the first one for each celebrity. And in order to do that, we're going to just extract the first image per celebrity and put it into a new directory. We're going to do that here by using OS and SH util. I'm going to just zoom in here, import OS, import SH util. Both are core Python packages. And we're going to say here for directory in os.list directory, celebrity faces dataset. Maybe let's call this data dir so that I don't have to constantly retype this. So data directory, then for file in os list directory, data directory, or actually we need to join the path. So os path join data directory and the directory that we already have from the first loop here for all the files in there. What we want to do is we want to just get the first file. So the first file is going to be os list directory, os path join data directory again. We want to get the first one. Actually, does this make sense? Let me just think about this here. No, actually, we don't need that. We don't need to iterate over the files. This is stupid. Obviously, we just need the first file here. So we need to say first file equals os list directory, and then just pick the first file. And then what we want to do is want to copy that file. So shutil copy file. We want to copy the file from the location. So from os path join. Want to join data directory, and first file. And we want to then move this to os path join, and we want to have a new directory samples, and we want to join this with a new file name, and the file name is going to be the name of the celebrity, so the directory name. So we're going to use an f-string here to say directory, and then just .jpg. That's that. Now we got a problem, permission denied. Oh, okay, we need to filter for that. So we're just going to, what are we going to do? We're going to say, first of all, let's see if it works if I just say 1. That would be a quick fix. No such file directory. Okay, we need to create samples. Let's see if that works. There you go. Works. So now we have for each celebrity 1 image in the samples directory, and it's always the first image, and the image also has the name of the celebrity. So I can just look at the file name to see which celebrity we're talking about here. Now, to do the actual matching, to do the actual lookalike search, we need to install a library called DeepFace. So we're going to open up the command line, and we're going to say pip install DeepFace. And DeepFace is essentially, I have made a video on this already, is essentially a lightweight Python framework that allows us to do face recognition and facial attribute analysis in a very easy way. So all we need to do here is we need to use the verify function of DeepFace and provide 2 images, and then we're going to get whether that person is the same person and how much the similarity is, how high the similarity is. So what we want to do here is we want to say from DeepFace, we want to import DeepFace like this. And we want to say here that we want to keep track of a smallest distance. The smallest distance is going to be none. And we're going to say then for each file in os list directory samples. So for each sample that we have, what we want to do is if the file ends with .jpg, just to make sure that we don't get the checkpoints again. So if the file ends with JPEG, we're going to take that file and we're going to see if that's the same as one of the files that we're looking at. So we're going to say here result equals deepface.verify. We're going to verify here person1.jpg, for example, or actually PNG in this case, for example, and the respective file. And the file, we're not going to join paths here. We're just going to say samples/file like this. And this will then return to us a certain output. Now, maybe before we automate this, let's just run this line separately here. Let's just go ahead and compute the similarity between person1 PNG and, let's say, Angelina Jolie.jpg. DeepFace is not defined. Okay, we need to, of course, import this. And then the result should be ready. Of course, it's going to download models. So if you run this for the first time, it's going to have to download the respective models. But the result then looks like this. First of all, verified means it's the same person. False. If it's the same person, it will say true. And then we have actually not a similarity, but a distance. So we have how far apart are those 2 images. And the higher the score is, the worse it is. So if it's a very low distance, that means that they're quite similar. If it's a very high distance, that means that they're not similar. So this is what we have, and this is what we're going to work with. So I'm going to delete this here again, and I'm going to say now we have this result. And if the result is verified, so if the verified field in that dictionary is true, we're going to just say print this person looks exactly like and I'm going to pass here file.split. We're going to split the file name on a point on the dot, because we don't need the file extension, we just need the name of the file, and we're going to pick just the first element here. And if this is an exact match, it's going to return this message, and we're going to break out of the loop, because if it's actually the same person, we don't need to keep looking. Otherwise, if we don't break, we're going to say if the smallest distance is none, so we don't have the smallest distance yet, so this is the first instance, we're going to just say smallest distance is equal to, and the smallest distance is going to be a tuple. It's not just going to be a value, it's going to be the file name, and it's going to be the actual distance. So we're going to say here file split on the dot, pick the file name without the extension, and then just result distance, like this. Otherwise, we're going to do that only if the distance is smaller. So we're going to say smallest distance is that if the result distance is less than the smallest distance 1. So the second position here. And otherwise, it's just going to be what it is already. And this is smallest distance. So let me just zoom out here. Smallest distance is this actual distance, this current distance, if the distance is less than the smallest distance. Otherwise, we're just keeping the smallest distance. Tuple. Distance maybe is a little bit confusing here. And then what we want to do is, if we didn't break out of the loop, so that's this for else structure, for we can break out of the loop, and if we don't break out of the loop, if the loop ends without breaking the loop, we're going to say else print no exact match found, closest match is smallest distance 0. And of course, this needs to be an F string. And that's basically it. So now what it's going to do is it's going to compare this person 1 PNG with all the different celebrities, and it's going to return the closest match. Now in this case, actually it says that this person looks exactly like Kate Winslet. Now that's definitely not true, because that's not Kate Winslet, but we can see if that is at least something that's reasonable. So this is the person we're talking about. If I go to the celebrities, Kate Winslet, I don't know. I mean, they have some similar facial structure, but yeah, I wouldn't say that that's an exact match. So let's go ahead and see what happens with person 2 JPEG. Let's see if we get an exact match here. In this case, no exact match found. Closest is Hugh Jackman. So let's see if that's true. I don't know. I don't know about this. So that's person 2. I mean, yeah, I see the similarities. And I also see that it's not an exact match. Probably better than all the other samples. I mean, Brad Pitt, not so much. Johnny Depp, not so much. I understand why this can be the most similar match here. But let's actually get to the interesting one. Let's see if it recognizes that Brad Pitt is actually Brad Pitt. So this is the actual match.jpg. This should be an exact match with Brad Pitt. It is. So it recognizes that this image here is the same person as this person here. So it recognizes this as the same match, as the same person. And now let's see if it also recognizes that this lookalike here is also supposed to be Brad Pitt. So I wouldn't be surprised if it tells me that this is an exact match. Let's see. Lookalike. What's the problem now? The file does not exist. Oh, it's a PNG. Okay. This person looks exactly like Brad Pitt. Okay, so it works. It doesn't work all the time. So for example, this is not an exact match. It's not the same person. This, you know, that's a very subjective thing, I would say. Is this the closest match? So is Hugh Jackman the closest match to this person? They're not so similar, but maybe they're more similar than all the other alternatives. But what's for sure is that this person was recognized as Brad Pitt, and Brad Pitt himself was also recognized as Brad Pitt. So this is actually quite impressive. So that's it for today's video. I hope you enjoyed it and I hope you learned something. If so, let me know by hitting a like button and leaving a comment in the comment section down below. And of course, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you much for watching. See you in the next video and bye.